Welcome to Section 410, Graphing Systems of Linear Inequalities. We're going to build off what we already know from the previous lessons. We kind of do inequalities after systems because it makes a lot of sense. There's a lot of parallels there. So we're going to graph each inequality in the system on the coordinate plane provided. We're going to shade lightly until you find the region that is common to all inequalities, and then we're going to darken the solution. So I'm going to kind of show you in one color what yours would look like. But then I'll start switching to different colors to kind of show solutions. But number 1 says y is less than 3. So remember, that's a horizontal line. It would be a dotted line because y cannot equal 3. Now, if we were shading lightly with our pencil, we would say y is less than 3. Kind of all down here. That's not our final solution, so you want to shade really lightly. Now I'm going to actually change colors so that you can kind of see what's going on. And then I'll try to, after we do it a few times, I'll show you what yours would look like in just one color. X is greater than or equal to -2, so if we go to -2, that would be the line at -2. It's a solid line because our X values can actually equal that line. Greater than that would be to the right. So our final answer would just be this shaded region. And we want to shade everything up to the dotted line of y equals 3, including the solid line of x equals -2. So that's any of these points. If we pick any point in this region, this red region, it will satisfy both inequalities. Okay, let's look at number 2. And I'm going to show you a tip that my teacher showed me so when you have one color. So we'll work in black. Alright. So in number 2, the first thing we have to do is we have to graph x is greater than or equal to 3 minus y. My suggestion is that you solve this for y, because your inequality sign is going to be a little bit different. So remember, when we divide by a negative, we have to switch the sign. So this problem is actually going to become, this will turn around and we'll have -x plus 3. So another way of saying this is y is greater than or equal to -x plus 3. Now if we graph that line, we have a solid line because it's equal to. Now, in terms of greater than, you might have remembered this from last year, but you might have forgot. You probably were taught to pick a test point. So, if you pick a test point, let's say 0, this is what you're testing to see which side you would shade on. 0 is not bigger than 3, so therefore you wouldn't shade the side of the red dot, you'd actually shade the other side. Now here's the strategy that my teacher taught me. Rather than shade and have all this messy lines, if I was still working in black, I would say greater than is actually above. That's what I was taught. Greater than means above. So once I have it in slope-intercept form, greater than is above. So above this line, I would just draw arrows to indicate that's part of the line for this line only. Now I'm going to go graph the 2x minus 3y is less than or equal to 6. I'm going to use the intercepts to graph that. So the x-intercept is going to be 3. The y-intercept is going to be -2. And because, again, this is a little tricky here, I'm not going to worry about the inequality sign yet. I'm going to go ahead and connect the solid line. And I can do one of two things. I can quickly test 0, 0, the red dot. And that's true. So that would be the side of the solution. Or I could put it in slope-intercept form to see it greater than less than, but I think it was easier just to test 0, 0 quickly. So this side of the line is shaded for that solution. So now you can quickly tell, based on the number of arrows, that your shaded region is that region there. Let's move on. Number 3. Now we have 3 inequalities. So we're going to graph x is less than or equal to 3. That would be to the left. Y is greater than or equal to negative 1. That would be above. And then if we graph x minus y is greater than or equal to 2, we can actually quickly graph the intercepts, negative 2 and 2. And that's a solid line. And if we want, we could have put this in slope-intercept form if you'd like to do it that way. Sign switches when you divide by a negative. So less than is below. So now when you consider this, it's this little triangle region. That's your solution. Now here's number 4. I'm going to give you a second. Can you go? I would like you to pause the video. By the way, sorry, I skipped a couple things. Let me go back up. The solutions. I have these answer blanks for solutions. Well, the shaded region is technically the solution, but if you want a solution, singular, all you have to do is pick one coordinate in the red region. So for instance, 0, 0 is in the red coordinate. A solution over here would be 3, 5. Because if you went over 3 and up 1, 2, 3, 4, 5, you'd find a point that's inside the solution. Down here, 0, 0 would be a solution. But the solution itself is all of the shaded regions, because any coordinate that's in the shaded region will satisfy both inequalities or all 3 inequalities, depending on the problem. That would be a singular solution. So number 4, pause the video and see if you can figure out what are the inequalities that would make up the shaded region. Okay, hopefully you've had a chance to do that. We're going to start off, and here is your answer. Y is less than 8/9 x plus 8. Y is less than negative x plus 5. And y is greater than or equal to 0. And kind of the things that you want to think about is, we have a negative slope here, we have a positive slope. This basically is reverting back to chapter 3, writing equations of lines in slope-intercept form, and then because it's less than, we know they're below the lines, and then greater than is above the line. So you fill in the equal to when it's solid, you do the dotted line, so you do less than for those. That's pretty much how you do number 4. Let's go on to the next one. Now we get into word problems, and at the end of the chapter we're going to get to what's called linear programming, and it's going to be kind of fun, some real world problems, and we're going to talk about that. But right now we're just going to get into setting us up some things. So we have Anna's about to take a test that contains short answer questions worth 4 points each, and word problems worth 7 points each. So right off the bat, you see short answer and you see word problems. Let x represent the number of short answer questions answered, and y represent the number of word problems answered. For each statement below, write an inequality. Ann must do at least 5 short answer questions. So x must be greater than or equal to 5. But time restricts us from doing more than 10. So, and, remember we talked about that a couple chapters ago, x must be less than or equal to 10. So if I was really writing this, I would probably write 5 less than or equal to x less than or equal to 10. That'd be my answer. Next bullet point. Ann must do at least 3 word problems, but time restricts us from doing more than 10. So similarly, we have 3 less than or equal to y less than or equal to 10. And the last bullet point, Ann can do no more than 18 questions in total. So x plus y must be less than or equal to 18. So now we have 3 inequalities for our system. And we're going to graph all of those. Alright, so we're going to start off with the first one. The first one is 5 is less than or equal to x, which is less than or equal to 10, but it's actually helpful to think of it with what we did originally. If we think of it with these separate ideas, It'll be more helpful when graphing. So we're going to go down and we're going to graph x is greater than or equal to 5. And we're going to graph x is less than or equal to 10. So right now we have to the left of the red, to the right of the blue. Now we're going to do the same thing for y. So we're going to go greater than or equal to 3. So we're going to go greater than or equal to 3. So we're up this way, and we're going to go less than or equal to 10 for y. Down here. So right now we have a box. The last one to graph is x plus y is less than or equal to 18. Much easier if you just do intercepts. So we go up to 18. And we go over to the 18. This was 10 here, 11. And we draw in our straight line as best of our abilities. If you have a straight edge, it'll be helpful. And less than that line is going to be down this way. So our shaded region is going to be this little trapezoidal region. And that's it. Okay, now I want you to pause the video and try number 6 all by yourself. And then once you resume, it will actually show you the answer. I'm running out of time that I'm allotted for these videos, so I'm going to just basically show you the final answer after you've done. Good luck. And here is the final answer to the problem. Make sure you define your variables when you do this. Make sure you graph all of your inequalities. Make sure you label your x and y axes, and then shade your final reason. Good luck on your homework tonight.